Today we're going to do more surface area, but we're also going to connect some concepts. If you remember from the day one notes, we learned that the surface area equaled the perimeter times the height plus 2 times the area of the base, or 2 times big B. We're going to apply that to a cylinder, and it kind of is the same. Okay, it really is the same, forget the kind of. All right, if surface area is perimeter of the base times the height, which is the distance between the two bases, well, do you remember how to find the perimeter of a circle? Another word for perimeter would be circumference. C equals pi times diameter, or you could say 2 pi r, couldn't you? Ah, okay. Wouldn't this be the perimeter? That's a very sloppy P. Wouldn't that be the perimeter? And H is the height, which is the distance between the two bases. And do you remember what the area of the circle is? Area equals pi r squared. So if I want 2 of them, wouldn't this be B? So actually, we're using the same formula. We're finding the circumference of the base, the perimeter, multiplying it by the height, the distance between the two bases. Then we're adding 2 times the base, which is the area of the circle. So when you first look at this, it looks like, oh my gosh, this is such a complicated formula, 2 pi r squared. It's the same thing. Far less complicated than you thought. All right, so let's go. Perimeter. Oh, and we're going to use 3.14 for pi. We will always tell you. Perimeter equals pi times the diameter. The diameter is 12. 12 times 3.14, that is a 4, trust me, equals calculator time. 12 times 3.14, 37.68. H is 8 feet, the distance between the two bases, and big B base is the area of the circle, which is, well, if the diameter is 12, the radius is 6, which is not pi. 3.14 times 6 squared equals 36 times 3.14 equals 113.04. Surface area, 37.68 times 8 plus 2 times 113.04. I'm just going to plug it all into the calculator. Let's see, times 2 equals plus. Oops. So I get 527.52 feet squared. Follow the directions, please. When we tell you to use 3.14, we do not want you to use the pi key on your calculator. The pi key will go far longer than 3.14, and your answer will be different, all right? You'll probably end up something like, perimeter, it'll all be wrong. Use 3.14. When you get into higher levels of math, you will use the pi key and you will round to a different place. For now, please follow the directions. Use 3.14 for pi if we ask you to, and don't round unless we tell you to. That's not so bad, is it? That was pretty easy. Surface area, you're using the same formula. Now let's find the lateral surface area and total surface area of a pyramid. New words. Lateral surface area, I'm going to write it down here. L for lateral surface area equals all the faces. Area of all the faces, not the base, the area of the faces of shape. I'll just say the shape. Okay, that's what the lateral surface area is. Lateral is the area of all the faces. So let's do some remembering. Area of a triangle, 1/2 base times height. I always put parentheses in, just what I do. So you're going to find the base of the pyramid. Let's see. There's the base. The base is shaded. The pyramid itself, oh, let's see. The lateral faces are congruent triangles. The base is an equilateral triangle. We give you all the information. So the area of the base is 1/2. Base is 3, small b base. Height of the triangle is 2.6. So let me just put in the calculator. 2.6 is 3.9 inches squared. That's the area of the base of that pyramid. Okay, the area of that triangle. Now you're going to find the area of one lateral face. It's a triangle, so you're going to use the same formula. Lateral face. Well, you know the base, the small b base, the length of the base is 3. This time it's 1/2 base. The height of the triangle is 4. So this is 6 inches squared. We tell you here, the lateral faces are congruent triangles, which means all 3 faces are the same. So the lateral surface area is 3 times 6, which is 18 inches squared. Because the area of each lateral face is 6 inches squared. You with me? Alrighty. Now you're going to use the net to find the total surface area. I'm going to write numbers. Okay? I know that this is 6, and this is 6, and this is 6, and this is 3.9. I'm just going to add them all up. So you have 18 plus 3.9, 21.9 inches squared. That's the total surface area. The area of all the sides, the faces, plus the area of the base. When you're doing a pyramid, you use a different formula. You find the lateral area, and then you find the area of the base, and you put it together. I think the next page, we're going to give you the formula. Or not. All right, now you're going to try it. Here's your square pyramid. Remember what I told you? The name of the shape is, the name of the pyramid or prism is the shape of the base. So base is a square. Not a quare, square. So the lateral faces are congruent triangles. The base is square. And here's what we have. The base is square, which means all 4 sides are 4 millimeters. So the area of the base of the square, well, the base of the pyramid, excuse me, would be 4 times 4 equals 16. That was easy. 16 millimeters squared. The area of one lateral face, triangle, 1/2 times the measurement of the base of the triangle, which is 4, times 6.2, which is the height of the triangle, equals 12.4. Let me double check the math, okay? Yep, all right. Now you're going to use the net to find the lateral surface area. We have you use the net because it's easy to count the faces. How many faces? We have 4. So the lateral surface area is 4 times 12.4 equals 49.6. So my lateral surface area is 49.6. My base is 16, so it's 49.6 plus 16, 65.6 millimeters squared. That wasn't hard. The net's really helpful because it lets you see how many pieces you have. Read the words. The words told us the lateral faces were congruent triangles and told us the shape of the base. Last page. All right, we're going to introduce a new term, and you do need this to find the area of a polygon. You know how to find the area of a triangle. Area equals 1/2 base times height. You know how to find the area of a square or a rectangle. Area equals length times width, or we could call it base times height. Let's keep with the same letters. To find the area of something with more than 4 sides, you need the apothem. Now, the apothem is the distance from the center to the edge of that shape, the apothem. So that is 6.9, the distance from the center of that pentagon to the edge. You need that to find the area. The area of that polygon is 1/2 times the apothem times the perimeter. Alrighty? That's going to be on that should be on your cheat sheet. So method 1, you need the area of the base. The area of the base is 1/2 times the apothem, which is 6.9, times the perimeter. Well, if one side is 10 meters and there are 5 of them, the perimeter is 50. So when we put it in the calculator, okay, I'm so not going to do this in my head. The area of the base is 172.5 meters squared. Let's see. So now you need the area of the triangle. I'm just trying to figure out what I have here. Oh, how fun, fun, fun. Okay, area of the triangle. We're going to actually have to calculate that. It gets fun. All right, let me do some annotation on my shape here. Remember, all the triangles, this is a regular pentagon, okay? It's not fancy, it's not wonky, everything's the same, which means all the sides, the faces are all congruent triangles. Which means we need to find the slant height, which would be this. I'm going to draw it in yellow. We need to find this. All right, we're really going to be bringing in the triangular geometry to this one. To find that yellow line, you need to use Pythagorean theorem. You need to find, I'm going to put the triangle in red. To find the yellow line would be the hypotenuse of that right triangle I just drew you in red. Look at the picture. I'm going to do this over here. I'm looking for L. L is slant height. Trust me on that one. So I'm going to use my Pythagorean theorem. We know that this little red line is the apothem, the one that I'm making bigger, and that's 6.9. And we also know that the height of this little triangle is 9 meters because it's written down for us. So I'm going to plug this into my calculator and we're going to find the slant height. We are using Pythagorean theorem. Do you see this right triangle? We've got the height in red, the base in red, and the hypotenuse in yellow. So calculator time. 6.9 squared plus 9 squared. So I've got the slant height and I'm going to round it to 2 places. The slant height is 11.34. So L, let me get into my yellow, 11.34. Actually, I'm going to round it to 1 place because my apothem is in 1 place. I'm only going to use 1 place, 11.3. You with me so far? I know it's a big one. It's a big complicated one. But you're using what you already know. You learned about the Pythagorean theorem in units 2 and 3. You understand how to find the hypotenuse. Now that we have the slant height, we're going to find the area of those triangles. So in this, oops, wrong color. It's too blue. The area of each face is 1/2 the base, which is 10. The height of that triangle, of the face of the pyramid, 11.3. You had to find the measurement. Okay, 56.5. So let me write up here what we did to find the area of the face. Area of face. 1, find slant height. And we're calling that L, lowercase l. And you did that by using Pythagorean theorem. 2, use area formula. So you're using the area formula a couple times in this thing. How many sides are there? How many faces are there? There are 5. So if one triangle is 56.5 times 5 equals 282.5. So the total, 280, I put it in the wrong place. 282.5. Put it all together and you have 282.5 plus 172.5. And you get 458. And that took us a long time. The formula is a little bit easier, but you still need to know the slant height for the formula. All right, big B, area of the base. P, capital P, the perimeter of the base. L is the slant height. You need to find the slant height sometimes. Sometimes we'll give it to you. All right, so let's look at the area. Let's look at the areas, all the work we did. So you've got T equals base, which is 172.5 plus 1/2 perimeter, which is 50, slant height, which is 11.3. Let's see if the numbers work out. 172.5 plus 85 times And I got 125.5. I think I wrote my numbers down wrong. Oops, I did right. Let me show you what I did. It's 455. I just took a look at my calendar, guys, my calculator, and I had inputted the wrong number. I added 175.5 to my my base area, so that was wrong. It should be 170. Go blue. Okay, because 172.5 plus 282.5 is 455. I simply put in the wrong number. You can double check my math. This all works. No, really, it all works. The toughest thing you're going to have to figure out is the slant height. Okay, we're going to give you the apothem, but you're going to have to sometimes find the slant height. So please look for the triangles. Look for the right triangles. Now, it's a lot easier when you're dealing with a triangular base or a rectangular base, because that's not so hard. Let's look at this one. The second one, method 1, find the area of the base. Without being told anything else, we can assume that this base is a square. We're not told it is not a square, so therefore it is a square. All right, the area of the base, 9 times 9, 81 yards squared. Area of the triangle, we have our slant height, it is 10. 1/2 small b times height equals 90, half of 90 is 45. Multiply that by the number of sides. There are 4 sides. So 45 times 4, I know many of you can do this in your head, you have 180 plus 81 equals 261 yards squared. Now, I'm going to use the formula. Okay, let's give it a shot. Big B base is 81 yards plus 1/2. Perimeter, well, it's a square, so the perimeter is 4 times 9 is 36. The lateral height, L, is 10 because we gave it to you. So 180 plus 81 is 261 yards squared. So as long as you're given the slant height, use the formula. It's so much easier. All right, last part we're going to do in today's notes, the last part is surface area of a cone. Okay, you've done surface area of a cylinder. You've done surface area of a pyramid, a couple of different types of pyramids. Now we're going to do surface area of a cone. Now, H is, let's see, L is, this is a lateral height. Lateral height. H is the cone height. Lateral height. This is a right cone. We call it a right cone because if you drop a line from the vertex of a cone straight down, it'll form a 90-degree angle. That is a right cone. Nothing slanted or squished. All right, so if you're missing any of these pieces, if you're missing the slant, the lateral height or the cone height, you can figure it out, and that's what we have to do here. We're making you apply what you learned earlier. We don't have the slant height here, do we? We know the height of the cone. We know this base part. We don't know the hypotenuse, so we have to find that. I'm going to do it over, I'll do it right here. So L, slant height, is the square root of 12 squared plus 9 squared. So let's put it in the calculator. 12 squared plus 9 squared. 15. Love it when you get a whole number. So we figured out the slant height is 15. L is 15. Let's do the formula. Now remember, I pointed some stuff out to you another time. the perimeter of the base. The perimeter of the base. What would that be? Well, that's called the circumference, which is called pi. Now, this is where this is the same formula, but it looks different. Remember, circumference equals perimeter equals pi d or 2 pi r. Let me show you something. 1/2 2 pi r equals pi times r. So that's what this is. This is 1/2 p. There's your slant height. This is big B base. So this is not a new formula. It is the same formula as this one. It's the same formula. But we used different, they put some different things in here. They used pi r instead of perimeter and things like that. You do it the way you want to, but I just want to show you it is the same formula. Okay, let's do the math. So pi times r times l, half the perimeter. Well, the radius is 9. Perimeter is 2 pi r. Excuse me. So let's do 1/2 times 2, 3.14. R is 9, plus the base is pi r squared, so 9 squared times 3.14. Alrighty? Let's do 3.14 times 9. Okay, that's 28.3, rounding it to 1. Okay? Plus, and the area of the base is 254.3. 28.3. Okay, this should be 282.6. And that would be centimeters squared. The last page shows you, the page 3 of these notes, shows you the formula to find the surface area of pyramids and cones. When you get to cones, if you want to keep things in terms of pi, you can do it. I simply wanted to show you how the formulas are the same. So practice this. You're going to have to find slant height. Remember what that is. And you should do fine.